Okay, so we're doing a real world land formation inquiry. And so what we have is a slideshow of different famous land formations around the world. And we're going to explore the internet to find out what type of boundary they are. Are they oceanic and oceanic plates? Are they oceanic and continental plates? Or are they continental and continental plates? And why that's important is because the type of plate and the interaction between the plate is going to determine what type of land formation will occur. So we'll also talk about how those plates move or interact with each other. We have a transform boundary, which means they slide past each other, a divergent boundary, which means they divide, and a convergent boundary, which means they're colliding. We will find a picture of the famous land formation and then an additional example of a different land formation that has the same type of boundary and the same movement. I won't be looking for a video for each one during this recording, but I will post the completed presentation with videos for each famous land formation. So the first one was done for us as an example of how it should look, and it's the Great African Rift Valley. And in the research, we found that it is a piece of land and a piece of land. So it's the continent of Africa. So it's continental crust and continental crust. And what's happening is the continental crusts are separating, they're dividing. So it's a divergent boundary. And what happens when the land starts to divide is the water from the ocean starts to fill where that land's breaking down, that valley. And so you get like a giant lake if there's ocean around. If there's no ocean, you just get a giant valley. It might look similar to how the Grand Canyon looks. Eventually, this piece of land will completely deteriorate and break off, and it will separate. These two pieces of land will separate. They will no longer be connected, and this will essentially be its own little island type. Jerusalem is another example, and you have two pieces of land that are separating, they're dividing, and the Dead Sea makes up that rift valley. So over time, as these plates continue to move away from each other, it's the African plate and the Arabian plate. As they continue to divide, the Dead Sea is going to get larger and larger. And then we have a video for you to watch on your own time. So through the research that I've done is Japan is a very interesting land formation, and we don't usually think of Japan as a land formation. We think of it as just a place, but it sits on 1, 2, 3, 4 different plates. So this island arc sits on 4 different plates, and they're all converging. So it sits on a land plate, a continental plate, and an oceanic plate. So the Pacific plate's oceanic. This one I cannot pronounce is continent. The Philippine Sea plate, and then the Eurasian plate. So you have 2 ocean plates and 2 continental plates. So a lot of interesting things happen as far as the island of Japan. They have over 100 active volcanoes, and they are a hot spot for major earthquakes and tsunamis. So when you watch this video, you'll see that Japan is actually quite a volatile place. It's a very dangerous place as far as plate tectonics is concerned. And all of this happens because these plates are colliding into each other. They are pushing into each other, and the oceanic plates are, because they're more dense, they sink underneath the continental plates, and they move a lot. These plates are always moving pretty significantly. So there is actually no other place that I could find in my research that is as unique as Japan. That is sitting on all 4 of these boundaries. That is no other island arc is formed by a continental and oceanic convergent boundary. So I thought that that was really interesting. So the next land formation we're going to talk about is the very famous Himalayan mountains. This is where Mount Everest is located. And Mount Everest is the tallest mountain in the world. And a fun fact about that is it's continuing to get taller. I think somebody mentioned to me it gets to be about a millimeter taller every year. That doesn't sound like a lot, but just the fact that this mountain is growing is amazing. So you have two pieces of land. You have India and you have Eurasia, and they're colliding into each other. And because they're both pieces of land and they have the same density or a similar density, they fold up. It's like if you push your fingers together, like you push your hands together, eventually they fold up and your hands fold together like you're praying. So they make folded mountains, and it's because two pieces of land collide into each other. And this video is a time lapse of that, so you can watch India and Eurasia collide together over the course of 70 million years. The video shows it a little faster, and it's really amazing to watch how these magnificent mountains were formed. Another example that a couple of my students found were the Zagros Mountains in Iran. Okay, so you have that boundary, that those two pieces of continental plates colliding and forming that mountain range. So our next famous land formation is another incredibly dangerous and volatile place as far as plate tectonics goes. So these are called the Aleutian Islands, and they're off the coast of Alaska. So they're actually like 55. It's a 55 island chain, and it almost connects Alaska to Russia, which I think is pretty cool. It's like a natural land bridge from our continent to Eurasia, and it's formed because of two oceanic plates. So you have oceanic and oceanic. But again, this is another area where and you'll see this in the video, where there's a lot happening that affects the entire island chain. So certain parts are affected in different ways. But when you have two oceanic plates converging, you will have subduction, because oceanic plates don't usually have the same density. So one of them will be more dense, and when it's more dense, it's going to sink. So when they collide, the more dense plate sinks below the other one. And that's how we get volcanoes, the movement, any type of plate movement causes earthquakes. It doesn't matter the type. There's earthquakes at all of them, but earthquakes are really frequent here. Volcanoes are really frequent here. And then the Aleutian Islands, as well as Japan, both have trenches. So trenches are also a factor in this type of boundary. So when two oceanic plates collide, the one that is the most dense will sink under, and that's how you get your volcanoes and your trenches. Another example were the Caribbean islands, and islands, they're interesting because they usually sit on more than one type of plate boundary. Because they're in the middle of the ocean, there's a lot that's going on. So that's a really interesting. Islands are a really interesting land formation. A lot happens there.